welcome to my channel. In today's video, I will be showing you how to implement text detection from images using OpenCV and Tesseract. This project is part of my computer vision assignment. First, we begin by import the necessary libraries for our project. We import CV2, which is the OpenCV library used for image processing, and we import NumPy as NP, a powerful library for numerical operations. And then we import Tesseract, which will allow us to perform optical character recognition on our images. And then we import PLT to help visualizing our result with plot and graphs. And next, we have a configuration string for our optical character recognition, or OCR. This line is defined as customer configuration, and you can check the parameter in the Tesseract document, and we choose the PSM6 as assumed as a single uniform block of text, and OEM3 is default based on what is available. And then we will allow the image using OpenCV. First, we specify the image path by using the relative path, and then we use the CV2 image read function to load this image and store it to the image variable. And this way, we can use this image in our subsequent processing steps. Okay, next we have the DBR to RGB function, and this can convert an image from BGR color space to RGB. This is important because OpenCV reads images in BGR format as blue, green, and red. And then we use the image point copy because we don't want the function to change our original image. And now I will use the BGR to RGB function we defined earlier and to show the RGB image, as you can see. And then we define a function called getGrayscale, and this function is responsible for converting a colored image into a grayscale image. We specify this parameter to perform the conversion, and the grayscale image simplifies the data and making it easier to process, especially for tasks like edge detection or optical OCR. And the function returns a grayscale version of the input image. And next, we will try this function we defined here. And as you can see, this visualization helps us confirm that the conversion was successful and that the image is ready for further processing. And you can see we use Tesseract image to string function to perform OCR on the grayscale image. This function extracts text from the image, and the result is here. And next, we define a function called Gaussian blur, and I give the default parameter 3. Okay, and this function applies Gaussian blur to the input image. And this Gaussian blur is useful for reducing noise and detail. And the parameter D is determine the size of the Gaussian kernel, and the large D results in a stronger blur effect. And we use CV2 Gaussian blur from OpenCV function to handle these functions. And the -1 parameter allows OpenCV to calculate the standard deviation based on the kernel size. And after applying the blur, we crop the image to remove any border effects or artifacts created during the blurring processing by slicing the image. Okay, and I will try to run this function. Okay, and in this part, I choose the D equals to 3, and it helps smooth out the image. This result allows us to see the effects, Gaussian blur, and okay, as you can see. And this is the result by using the Tesseract image to string function. And we can compare these two results. It's a little different. This part maybe it is less than this part. Okay, and next we define a function called thresholding, and this function applies the thresholding technique to the input image, and which is a crucial step in image processing for converting grayscale images into binary images. Okay, and the 0 and the 255, we set the threshold, minimum threshold, and the maximum threshold. And these two functions can automatically determine the optical threshold value based on the image histogram. And try to run this function. And in this part, I input the gray image by using the function we defined earlier, and you can see the output and compare with the result. Don't have too much difference, maybe the same. Okay, next we define a function called canyon, which can implement the canyon edge detection algorithm, and this technique is widely used in image processing to identify edges in an image, making it easier to analyze shapes and structures. In this function, we utilize the canyon from CV2, and the parameters threshold 1 and threshold 2 are the lower and upper thresholds for the edge detection, and by default I set threshold 1 to 30. Okay, and in ensuring we have a proper range for detecting edges. And then after defining our canyon edge detection function, we can apply it to the grayscale image by calling this function. Okay, here we specify the default parameter, and we can see the result and the output image. And this allows us to see the edge highlighted, providing a clear view of the structures within the image. And also I use this function and compare the result. There's not too much different. Okay, and then we define the Sobel X function and the Sobel Y function, which implements the Sobel operator for edge detection. This method is particularly effective for detecting edges in the horizontal direction, and this function is vertical direction. Okay, we just and this code is to convert this result into a format suitable for visualization. We normalize the image using this function normalize. Okay, because the output is a string, and this one should receive a unsigned integer. Okay, then we can just run this code, and you can see the result is not good at all, and it's I try the Sobel Y. Oh, and as you can see, this is even worse, and you can't recognize what's happened and what is. And then I define the edge detection function, and this integrates several steps to detect edges in an image using the canyon edge detection algorithm. And the function sets 3 parameters, and cause it will transfer this to those two functions we defined earlier. Okay, and I will copy the image first, and then custom blur this image and get grayscale. And finally, I use the canyon edge detection algorithm to handle this image. Okay, and we color the detected edge in bright green on our original image, on our copied image, by setting the corresponding pixel. And I will try. As you can see, the detected edges will be highlighted in bright green on the original image, by this image. Okay, and allowing us to visualize the important feature clearly. By executing this line, we can see effectively the edge detection works on our input image. Okay, next, we define the detect character function, which is designed to identify and annotate characters in the given image using Tesseract's OCR capabilities. Instead, the function we first retrieve the height and width of the image, and we can call this function is different the image to string. I use the image to box here to get the bounding boxes of the detected characters, and this function returns a string containing the characters information, which we split into lines for processing. And for each line, we extract the characters coordinates x, y, w, and h, and then we use the rectangle function to draw a green rectangle around each detected characters, and it can provide a clear visual indication of where each character is located. Additionally, we annotate each character on the image using putting text. Place the character itself above the rectangle in the blue text. Okay, and I will try. Okay, I forget. Show it. As you can see, we can visualize the characters detected in our input image, along with their bounding boxes and annotations. Okay, next I want to show you the next function is detecting words. Okay, it extends our character detection to recognize the entire words in the image using the OCR capabilities. Okay, and we also change the function. We use the image to that. It's including bounding boxes for each word, and this function returns a string that we split into lines for processing. We iterate through these lines, keeping the first one since it contains header information. For each subsequent line, we checked if it contains the expected number of elements. Well, if it does, we extract the coordinates x, y, w, and h for the bounding box, and we'll draw a green rectangle around each detected word. And then we also annotation the word itself above the rectangle with put text. And let's run this function. And as you can see, we can visualize the word detected in our input image, completed with bounding boxes and annotations. And I want to show you the structure of the output. And this is the reason why these two functions have different literature. Okay, and print. And as you can see, they just have 1, 2, 3, 4, 5, 6, and you can see the I, and this is the location of the characters. And I will show you another structure. Okay, and it's quite different. So, and this is the reason why we use 6, 7, 8, 9 here, and use 1, 2, 3, 4 here. And this function we use enumerate to execute this one. It's called the header information. Thanks for watching. I hope you found this tutorial on this project on text detection using OpenCV and Tesseract helpful. And if you enjoyed the video, please give it a thumbs up. Okay, and if you have any questions or comments, feel free to leave them down below, and I will be sure to get back to you. Thank you.